Okay, good morning class. Alright, can the monitor please check who's still not here? So I can put in the parents group. Okay, so we will start for the presentation today. Okay, so we got one volunteer. Okay, want to start first. Okay, very good. Alright, so Wang Jen Yep, are you here? Wang Jen Yep? Yes, teacher. Okay, so are you ready? Yes, okay. So you can start share your screen.
Teacher can see my screen. Good morning, Puan Yusfalina and all my friends. Today I'm going to present about a rubber band pedal boot. The contents of my presentation is the materials used in this project, steps of making the model, physics concept used in this project and explanation about the project, video and results of the project, and the last is reference. The material I use in this project are ice cream stick, rubber band, scissors, glue, small knife, and marker pen. Now I'm going to introduce the step I'm making this project. The first step is prepare 3 ice cream sticks and cut one of them into half, then stick them together like shown in this picture. And the second step is use a marker pen to mark down the width of the sticks and cut it. Stick them one by one as shown in the picture. After that, mark 4 bottoms of the sticks and cut them down. Paste them into the model shown in the picture, like this. And the fourth step is take 2 long ice cream sticks and stick it onto the model. After that, cut the side of the model to make it look nicer. And put a rubber band into the hole and pull it back as shown in the picture. After that, prepare 2 bottoms of the stick and stick it together to become the pedal wheel of the pedal boot. Then put the pedal wheel into the rubber band and finally the model is done. Now I'm going to explain my concept used in this project. The first is every action has its equal and opposite reaction, which means that when properly apply force to water in backward direction, then water also gives equal force to boat by which is moved in front. And the second is these boats run on energy stored in the rubber band attached to the pedal wheel. As you wind the pedal wheel, the attached rubber band also wins strong muscle energy. When released, the rubber band unwinds, in turn causing the pedal wheel to rotate and the boat to move. Now I'm going to show my video and the result of my project. As you can see, when I spin the pedal wheel and I put into water, the pedal wheel will rotate and move. Like this. And the last is these 3 links is the reference I use in this project. And that's all.
Can you play again the video?
Oh, okay. And that's all of my presentation. Thank you.
Okay, thank you. Give me for a moment. Okay. So we move on to the next presenter. So I will choose the name. Okay. Alicious, are you here?
I can't present because my computer is having like system issues right now.
Okay. So when you can present?
I think when my computer is fixed because my computer right now has like some system issues.
Hmm. Okay. All right. So we move on to the next. Okay, Elvis. Elvis Chong Zi Chen. Elvis, are you here? Elvis. He just told me his line not good. Okay. Who? Wai Hong or Elvis? Elvis. Okay. Okay. Let me tell you something. Okay. So they say if you cannot present, right? Because you have marks for presentation. So if you can present, I cannot give you marks like 20 marks for the presentation. Okay. So if you have to present either way, also you have to present. But let's say the school open, okay, when the school open, because some of you text me said your line is not good, you don't have the laptop, okay, you have a issue, technical issue, okay, so you have to present when the school open. Okay, so whatever happened, you still have to present. Okay, if not you will lose 20 marks here. Okay. So you don't think like, okay, I give you excuse now, so you don't need to present at all. No. When the school open, yes, the school will open. So you have to present. So on the first day on school, okay, we start the class. So you are the first one who will present. Okay, for those who text me. Okay, and then another one for those who didn't submit the presentation in the Google Drive, is considered you didn't do the project. So make sure you put your PowerPoint, okay, as a proof that you already did the project. So if you don't put the Google Drive and I check, so means I will just deduct your marks. Alright. So I will not tell you about this anymore. So please, okay, if you have any problem, please tell me earlier. Okay. Alright. So we move on to the next one. Chiang Zinian, are you here?
Yes,
Chiang Zinian. Chiang Zinian.
yes, teacher.
Okay. So can you present today?
Yes.
Okay, very good. All right. So I will start share my screen.
Good morning to Puan Youth and my fellow friends. Today I will present about my physics project which is a working evaluator. The materials and apparatus that we need is scissors, hot glue gun, cardboard, cylinder cardboard, stick, and string. First, we need to use the cardboard to make a small box. Second, we need to cut the bottom of the two-cylinder cardboard and fold up. Third, we need to tie a string on the both sides of the box and tie the string to the stick. Then, we need to insert two holes at two sides of each cylinder and insert the stick to the hole. The physics concept of working elevator is normal force. Normal force is the force a surface exerts on an object. Normal force is always perpendicular to the surface. In case 1, the lift remains stationary. So the formula we use is F equals to mg. In case 2, the lift moves up with acceleration. The formula we use is F equals to mg plus ma. In case 3, the lift moves down with acceleration. The formula is F equals to mg minus ma. This is the video of the working elevator. That is all for me. Thank you.
Okay, sure, Kenzie. Good. All right. Give me a moment. I want to.
Teacher, can you see my screen?
Yeah, I can.
Good morning to my teachers and my fellow friends. My title is Momentum of Gun. The material for me to use is paper, cellophane tape, rubber band, scissors, and hot glue gun. This is the method that I do the gun. First, I roll the paper into long shape. Next, use the paper to make short roll. Stick two short roll together. Next, I use color paper to make a cuboid and roll 3 pieces of paper into one and cut it into 8 cm each. I stick 2 8 cm short roll on top of the cuboid and hang the rubber band on the 2 short paper roll that stick together just now. But put the things into the cuboid and the short roll. Stick 3 9 cm roll at the bottom of the cuboid. Next, make the short roll into shape of 7 and stick it. Make a trigger here. And the paper gun is finished doing. The explanation is gun recoil is certainly some things we are aware of. Gun recoil is a result of momentum conservation, which is an extremely important fundamental principle. Newton was talking about momentum conservation when he wrote every action has an equal and opposite reaction. However, the physics behind all guns remain the same. Momentum characterizes an object's resistance to change in motion. If this is motion along a straight line, we call it linear momentum. If it's rotational motion, we call it angular momentum. The basic idea is the same. Moving things like to keep moving, and to change their motion we have to apply a force. This is the modification that I do. The mass of the materials must heavier. To increase the momentum, use rough and hard material to do trigger, to let the firing pin stop when without using the gun. The bullet of the shape need to be ogive shape to let the bullet less force when shooting. This is the video that I make. And this reference. Thank you.
Okay, can you please play the video again?
Okay. Teacher can already.
Okay, thank you.
Thank you.
All right. Okay, so thank you for Xinyan and also Tianxing, right? So we go to the next presenter. So any other people want to volunteer? All right, very good. Yes, very good. Right, so you can continue.
Teacher, can you see my screen?
Yeah, I can.
Okay. Good morning to Buan Yus Falena, to my fellow friends. My name is Li Xingqi and I am from class 4K. Today, I would like to introduce to you guys about my car, which is an elastic band powered car. So first of all, the material that I use is scissors, cutters, wooden sticks, bottle caps, marker pen, plastic bottles, and rubber band. So the first step we need to do is draw a rectangle on the middle part of the plastic bottle, then cut the marked part using cutters. The third step we need to do is make 4 holes on the plastic bottle and put wooden stick between them. Then we also need to make a hole on the bottle cap and connect it with the wooden stick. Then the fifth step we need to do is cut another plastic bottle into half using cutters. Then we also need to cut the half bottle separately using a pair of scissors. Then next, we also need to connect the upper part of bottle using a wooden stick and bottle cap. Then we also need to put the upper part of bottle behind the car. The ninth step we need to do is tie up the wings and the car by using rubber bands. Last but not least, we also need to connect the rubber band with the bottle cap and close it tightly. So this is my final product and this is the video. Okay, the explanation of this product is the physics concept used in this product is elastic potential energy. Potential energy is formed when the rubber band is twisted. When the rubber band is released and it starts to unwind, the potential energy is converted to kinetic energy as the car is propelled forward. The more you stretch the rubber band, the more potential energy is stored, and the farther and faster the car should go. The kinetic energy form allowed the car to move forward. So the modification that I done is more rubber band are used to increase the kinetic energy so that the car can move farther. The wing of the car is enlarged so that the car can move faster. So this is the reference that I done. That's all from me. Thank you.
Can you play the video for me again? Sorry. Thank you.
Okay, thank you.
Okay, any other volunteer you want to present? Okay, very good, Daniel. Okay, you can continue.
Teacher can listen.
Yeah,
Can you
I
listen?
can.
Okay.
Yeah.
So, good morning to the teachers and my fellow friends. So, my physics project is the balloon power car. Okay. So the material used are knife, scissors, nail, hammer, 4 caps, bottle caps, balloon, masking tapes, 3 straw, 2 bamboo chopstick, and a water bottle. So the step 1 is cut 2 of the straw using a scissors below so that it will fit inside the balloon bamboo chopsticks. Second is stick another straw with the balloon using a masking tape so that the that we can inhale inside the gas lah. Step 3 is cut a square hole at the water bottle so that the straw can fit in. Step 4 is use the 2 straw that you cut during step 1 and stick it below the water bottle using masking tape so it become a tire like this. So step 5, you can see you must use the hammer and the nail that we prepared to pierce a hole at the 4 caps and put 2 caps to each bamboo chopstick and put the bamboo chopstick into the straw. So you can see the module is almost out now. And the last step is put in the balloon and the straw that we prepare at step 2 into the hole that we cut in step 3. So what physics concept are being used at this balloon power car is the Newton's third law. When you inflate a balloon and let it go, it zips randomly around the room. When you tap the balloon to a straw and attach it to the body at your car, however, you can control the direction of the escaping air. When the end of the straw is aimed backward, the air pushes your car forwards, as described by Newton's third law of motion. Your design will be more efficient if the straw is painted straight back and not downward or to the side. The more you inflate the balloon, the more potential energy it stores, which then is converted to more kinetic energy, according to the law of conservation of energy. So the car will go faster. So what did I modify is I make the straw that need to inhale the balloon and I make it bigger than the one that used to the tire one. So I changed the straw that I used to connect the balloon to a bigger and thicker straw. This is the reference that I use, and this is the video. So the bigger the balloon, the more distant you can go. This my balloon are smaller, so I can go just a short distance. Thank you.
Okay, thank you. Okay, any other want to volunteer? Or we give you extra mark if you volunteer. Okay, very good. Chan Zing Zing. Okay, you can share your screen now.
Teacher, can you see my screen?
Yeah, I can see your screen.
Okay. Hi everyone, my name is Chan Xingzhen and my physics project is rotating ring. The materials used in the project are candles, cardboard, lighter, cup of sand, chopstick, and scissors. The first step of making the project is draw a diagram based on the photo below on the cardboard and cut it out. Then, cut the cardboard following the line by using a pair of scissors. After that, fold the cardboard and concave it. Next, put candles on the cardboard. Then, insert the chopstick into the cup of sand to help the chopstick stand vertically. After that, put the fan on top of chopstick and make sure it is stable. Later on, put the cup of sand in the middle of the candles. Light up the candles carefully and use the cardboard to block the air from surroundings and not to affect the result of the product. Later, you can observe that the fan is rotating. The physics concept being used in the project is convection currents in air. When the candles are lighted up, the air from the candles are heated. The hot air from the candles will rise up and cause the cold air to move out and sink. This movement causes the fan to rotate. Thus, it indicates the flow of convection currents in an upward direction. A convection current is a process that involves the movement of energy from one place to another. It is also called convection heat transfer. The modification done to the object. We can add candles around the fan so that it will rotate in a longer time. Then, poke a hole in the middle of the fan so it is more stable. This is the Now, I'm going to show the video of end result of my project. Now I'm just show the video again. And this is all my reference while doing the project. That's all from me. Thank you.
Okay, very good. So any other want to volunteer? Yes, sure, Alice. Okay, very good. Okay, you can continue. Share your screen.
Hello and good morning to my teacher and fellow friends. Today I will present stick explosions, kinetic and potential energy. The materials used are wooden popsicle sticks, Jenga blocks, and rubber bands. Sorry, it's a bit laggy. Making the project. Step 1. Make your first lever. Step 2. Build a second lever, omitting the rubber band. Place the open end of the lever between the sticks in the first lever right next to the block. Repeat step 2 as many times as you please. To detonate the explosion, remove the rubber band at the detonation point while pressing down on the free end of the sticks.
Alice, did you change the slide? Because mine is show the make your first level. Is that this is the slide you are presenting now?
Wait. What do you mean?
I mean, which slide are you presenting now?
I'm presenting this slide.
To detonate, is it? To detonate your stick explosion, is that?
Yes.
Yes, okay. Alright, continue.
Okay. How physics concept is being used in the project. Kinetic energy. Kinetic energy is the energy of an object in motion. In this experiment, the kinetic energy is the energy of the moving sticks as they fly away. Potential energy. Potential energy is stored energy. In this experiment, the levers have a lot of potential energy stored in both the stretch rubber bands and the popsicle sticks held in tension. Modification done to the project. Doubling the sticks used. This is to harness more potential energy and thus making more flying sticks. This is the modification of the project. This is the reference. Thank you.
Alice, I cannot see any video, but my screen now just show to detonate only. Starting, you start, yeah, then after that I cannot see others slide.
Can you see here?
No.
Can I send it to you in WhatsApp?
Yeah.
Okay.
Okay. So you already finished, is it?
Yeah.
Okay. So any others want to present? Okay, good. Su Li Ying. Okay, can continue.
Good morning to my teacher and my fellow friends. Today I would like to talk about my physics project, and it's called Archimedes cube. For the material I use in this project is thin cardboard, scissors, cylindrical container, straw, and also the UV glue. For the procedure, first you need to measure the radius of the cylindrical container. Second, cut the thin cardboard into many circle shapes, and the pipe is using the radius which measured just now. Third, you need to drill a hole which is suitable to put in the straw in the middle of the circle-shaped cardboard. Fourth, share the circle and link out all of it by using the uhu glue and use the straw as a center pillar to form a spiral shape. Fifth, put in the next spiral-shaped cardboard into the cylindrical container. And last, you need to cut a hole beside the bottom part of the cylindrical container. And for the explanation of this project, the Archimedes screw is made up of a hollow cylinder and a spiral part. One end is placed in a low-lying source and the other end is tailed up into a higher discharge area. To move the source, all you need to do is just rotate the screw, and when the screw turns a half rotation, it scoops up sources and hold it in a fixed position. Because of the angle of the screw, an Archimedes screw cannot be vertical. Gravity and the normal force in the screw thread and cylindrical ball cause the sources to be in a stable equilibrium. Even if you stop turning the screw, the sources will remain trapped in a potential belt. And for the modification, you can use waterproof material to transport more type of sauce, and you can also use harder cardboard to let it don't break easily when transport heavier thing and let it more easier to fix the ship. And this is the video because I use the thin cardboard and so that it will it is not beautiful when we use it. And these are my reference, and that's all for me. Thank you.
Okay, thank you, Su Yin. Right, so we go to the next one is Lu Ling Jin Yi. Okay, after that is Chang Weng Shen, and then after that Wu Ying Wei. Okay, so very good.
So, teacher, can you hear my voice?
Yeah, I can hear your voice.
And can you see my screen?
Yeah, sure.
Okay, so good morning to my Huan Yu Fanina and my fellow friends. I'm Lu Jingyi from class 4K, and today my physics project is hydraulic crane. So before I talk about my project, I would like to tell you what is a hydraulic crane. A hydraulic crane is a working model of to help us to understand about hydraulic technology. And hydraulic crane is a heavy-duty machine that is basically used for lifting and loading heavy loads. Hydraulic press uses a hydraulic cylinder to produce a compressive force. So now I'm going to talk my materials. I'm using two.
Excuse me. Sorry. Lu Ling Jin Yi. Jin Yi, did you change to another slide?
Sorry.
Did you change to another slide?
Uh,
Because mine's still at the title there, physics project, your name, your class.
oh. So.
The slide doesn't change. Still at the
Doesn't change.
first slide. It's still at the first slide. Yeah, now it's changed.
So it's the second slide, right?
Maybe you can go to the slideshow there.
Slideshow. Do you see this is the second slide, right?
No, this is the first slide. That I see this first slide. Yeah, this one I see the second slide. Now it's back to first slide. Now it's third slide.
Okay. So now it's the first slide, right?
Yes.
Okay. Now it's the second slide.
No.
Oh.
Yeah, now is second slide.
Now a second slide. So I will just do it like this. Huh?
Right,
So
right.
I would like to tell you what is a hydraulic crane before my procedures. So hydraulic crane is a working model that will help us to understand about hydraulic technology. And a hydraulic crane is a heavy-duty machine that is basically used for lifting and loading heavy loads. And last, a hydraulic press uses a hydraulic cylinder to produce a compressive force. So now I will be going to introduce my materials to make my project. So you can see, right, this is the third slide. Hello. So this is my third slide for my project. So I will going to use two 20 ml syringe, a cardboard, bamboo stick, plywood, 4 mm PVC plastic pipe, and the apparatus is a scissor, knife, and glue gun. So now to my procedures. So the first step is prepare all the materials that we need to use. And the second step is make a hydraulic crane shape by using a cardboard. Yeah, as you can see in here. Lah. So the third step is like connect the PVC pipe to the two strings here to make a pressure thing here. And step 3 is make a box to carry things. And the last, we just connect all these things by using a glue gun. And yeah, that's all. So now to my video. Okay, in this video, as you can see, right, I just press the back here, the syringe, to reduce the pressure in here, but increase the pressure in here. So the syringe in here will lift up the heavy load in here. So the next video. Okay, so in this video, as you can see, I increase the what is it called? The pressure in here and reduce the pressure in here so that it comes down. So you guys clear? What am I saying? Hello?
Yes.
Oh, okay. So now to my advantages. The advantages this hydraulic crane is always we can see in our daily life as some construction or anything. So there are many advantages of it. So the one of them is the built-in overload protection, and is very safe compared to the mechanical press. And it is compact and in a lower cost, so that it will save money. And it is quiet. Yeah, they're quiet when they're operating the hydraulic press, and it provides full power stroke, so it's easy to lift the things, the heavy things. So, but advantages, there are also advantages and disadvantages in this hydraulic crane. So one of the disadvantages is handling of hydraulic oil can be messy. Yeah, they will sometimes they will have oil when you're using it lah. Right, and the hydraulic line could burst due to excess pressure. Some hydraulic fluid can catch fire because it's easy on fire, so you must be very careful when using it. And there are chances of hydraulic fluid leakage, and the system get heated because of hydraulic fluid is forced through the pumps, and it has low operational speed, and they have relatively high energy consumption. And in our daily life, we have many types of hydraulic presses, and there are five types in here. So one is universal hydraulic press, vertical frame hydraulic press, horizontal hydraulic press, single column hydraulic press, and the last one is 4-column hydraulic press. And the last, I'm going to talk about my concept. The concept of my hydraulic press is like the Pascal principle. which is established by French mathematician Blaise Pascal in 1648 and to 1648. Pascal's principle is a principle in the fluid mechanics, stating that the pressure at a point has infinite directions, and thus the pressure change at any point in a confirmed incompressible liquid is transmitted throughout the fluid, such as the same change occurs everywhere. And this is additional knowledge about Pascal. And you want to know not like in the 40s, a mathematician called Blaise Pascal invented the Pascaline in early calculator and further validated Evangelista Torricelli's theory concerning the cause of barometrical variations in the 50s. Pascal laid the foundation of probability theories with Pierre de Fermat and published the theological work Les Provinciales, a groundbreaking series of letters that defended his Jansenist faith. Pascal is also who widely known for his body of notes posthumously released as the Pansies. So that's all for me. Thank you.
Okay, so very good presentation. Okay, very detailed. Okay, so actually, okay, Lu Lingjingyi, he knew what he did. Okay, for the project. Okay, so I will give you highest mark. Okay, that's the highest mark for until now. This is the highest mark. Okay, so very good presentation. All right, so we goes to the Chan Weng Shen. Okay, so you can continue.
So teacher, can you see my screen? Teacher, can you see my screen, teacher?
Yes, I can see your screen.
Alright. So good morning to Puan Yuspalina and my fellow friends. I'm Chan Wing Shen. So today I'm going to present about my project, which is the magnetic sensory bottle. So the physics concept applied in this project is the magnetism, magnetic dipole, and the magnetic field. The material that we use in this project is the 3000 ml of the plastic bottle and a magnet, iron fillings, one plastic container of water, and a HM plastic bag. So how is it correct? Make sure all of the material and apparatus is ready. First of all, make sure inside of the water bottle is as dry as possible to prevent the iron filling is going to rust. After that, put the iron filling into the HM plastic bag to prevent the iron filling spread out to the surrounding area. Then put the iron fillings into the plastic bottle. This is the iron filling. Put one plastic container of water inside the plastic water bottle until it's full. Make sure the water inside of the plastic bottle is clean. If not, filter it out until the water is clean. And a simple magnetic sensory bottle is created. So why the iron filling will have reaction when magnetic is near? Iron filling will attract by the magnet because of magnet have a strong magnetism. Therefore, the iron filling will have reaction when the magnet is near with it. Besides that, to let the magnet stick on the bottle, the magnet must have the bigger magnetism to attract more iron fillings. Therefore, the more iron filling attracted, the more possible that the magnet will stick on the plastic bottle. Modification. So we can change the iron filling to paper clips, pipe cleaner, or bolts, screw, or the stapler clips. But we need to change the water into the baby oil. Besides that, you can change the iron filling to iron powder, but iron powder maybe will cause more dangerous situation because the iron powder is a chemical substance. Besides that, we can use another magnet as long as we have the strong magnetic field. So this is the video that I tested out the things. Yeah, so this is the reference that I refer to. Thank you.
Okay, thank you. So now we move on to Ui Ying Wei. Okay. So are you ready, Ui Ying Wei?
Yes, teacher.
Okay.
Teacher can see my screen.
Yes, I can see your screen.
Okay. So, good morning to Puan Yus Falina and my fellow friends. Today, I'm going to talk about my project, which is Infinity Mirror. So the content in this is I have introductions, list of material used, picture of making the project, how physics concept being used in the project, modification done to the object and the reference. An infinity mirror creates an optical illusion of an infinitely long tunnel. It actually consists of two mirrors, a regular mirror and a one-way mirror, with light-emitting diodes LEDs sandwiched between them. When the LEDs are turned off, the infinity mirror acts just like a regular mirror. But when the LEDs are turned on, the infinity mirror looks like a brightly lit tunnel that stretches off to infinity. The reason why you see objects is that light hitting these objects reflects back into your eyes and then is uh, perceived and represented as those objects by your brain. But what happens if light coming from an object hits a flat mirror and is reflected or bounced back before it hits your eyes? The brain, being unaware that the light was reflected, will construct an image with the information it received, assuming the light traveled on a straight path from the object to the eye. The result is what you see in the mirror, an object that looks similar but appears to be placed behind the mirror. We call this a reflection of the object. It is an optical illusion, a virtual image of a real project. So the list of material used in this project is plexiglass, reflective window film, LED lights, a cardboard cover, a box, and a mirror. So this is the steps to making the project. So first, cut a square hole on the cover that you have prepared. Second, stick the reflective window film and the plexiglass together. And third, tape the plexiglass onto the cut cover. Fourth, so next is the reflective side. Next you put the stick the plexiglass and the window together. So next, you take the reflective, the stick plexiglass and the plain mirror into the cover that you created. And then next is put the LED lights into the box and as is shown. And then last is put the cover on the box. So the end product will look like the picture at the bottom. So after you turn on your LED light, your product will look like this. It is an infinity mirror. So the infinity of the effect of the infinity mirror is that you will see a brightly lit up tunnel that stretches on to infinity and make it an optical illusion. So the picture below is showing a proper product of the project of proper product. It is shown that it is like a brightly lit up tunnel that stretches on to infinity. So how an infinity mirror works is like the light bounces back and forth between mirrors, and second is some light escapes the front mirror each time because it's not totally reflective, Then third is each time light escapes the front of the mirror, less light is reflected towards the back. Fourth is the observer sees progressively dimmer illusion LEDs behind the real one. So as you can see, the first mirror is real mirror 100% reflective, and the second front mirror is 50% reflective, 50% transmittive. So the 3D illusion mirror effect is produced whenever there are two parallel reflective surfaces which can bounce a beam of light back and forth an indefinite number of times. The reflections appear to recede into the distance because the light actually is traversing the distance it appears to be traveling. For example, in a 2 centimeter thick infinity mirror with the light sources halfway between, light from the source initially travels 1 centimeter. The first reflection travels 1 centimeter to the rear mirror and then 2 centimeters to and through the front mirror. A total of 3 centimeters, the second reflection travels 2 centimeters from front mirror to back mirror, and again 2 centimeters from the back mirror to and through the front mirror. So it's totaling to 4 centimeters. Plus the first reflection, which is 3 centimeters, making the second reflection 7 centimeters away from the front mirror. Each successive reflection adds 4 more centimeters to the total. So the third reflection appears 11 centimeters deep, fourth 15 centimeters deep, and so on. So each additional reflection adds length to the path the light must travel before exiting the mirror and reaching the viewer. Each reflection and the additional distance traveled by the light reduce the brightness of the image, which is also fade into the distance. So the modification done to the project is infinity mirror can vary in size, shape, color, and complexity. You can build a relatively small mirror similar to my project to a table size. So if you want the mirror to be more bigger, you can use the more bigger box and a more bigger mirror and everything in a bigger size. So the below is my reference to my project, and the teacher the video I will send through WhatsApp. So that's all to my project. Thank you.
Okay, so thank you, right? Okay, so I think we only got like 4 minutes, and I'm not sure whether we still have enough time. Okay, so but next week, right? So next week we start with Ng Yong Wei, okay, Chi Wei Lok, and also Ang Wei Min. I'm not mistaken. Yes, Ang Wei Min, and another one Chung Wei Zhen. Okay, so I already write your name here. So tomorrow we continue. Okay, with this 1, 2, 3, 4 students. Okay, so I think I will stop until now. So I see you on next Monday, and please submit. Okay, for those who still didn't do the tutorial 5.1, please submit before I put your name in the parents group, right? So please do it. All right, so thank you, class. All right, very good presentation for today. Okay, so take care, everyone. Okay, see you next week. Okay, welcome. And the monitor, please send me the attendance for today.